Hey students, wanted to talk with you real quickly about some inverse relation and functions. Now this is different than an inverse operation, right? If you were solving just a random problem like this, x plus 2 equals 8, you would use inverse operations to get x by itself. But we're going to start talking about inverse functions, and they correlate very nicely to one of the things that was composition. Right, we did an operation of composition. Because of the time crunch here coming at the end of the year, we're not really going to go into major depth about it. So we're just going to show you really two basic things that you need to know here about inverse functions. Before we get to it, just a reminder, the MathXL that you were assigned on Tuesday or Wednesday, depending if you're first, second, or eighth. It is due. You have an extension on it. Really wanting you guys to get some time in on working that review on radicals. So that was something I told you in class and has been made known on the Canvas page. So use that time today in class to obviously do this, but look at the two MathXLs that I'm going to talk to you about here. All right. First thing is this inverse function. How we get that is we could do two things. All right, basically that's what we're going to do. In a table, all we have to do is take x and y and we switch the order of them. Okay, that's the first thing that we're going to do when we're trying to find an inverse, right? So you can see right here that this is just a mapping diagram, and basically in which you would see a list of x values and they just compare to the y. So in this specific mapping diagram, you have four different points. You have the point of 1.2, 1, 1.4, 1, 1.6, 2, and 1.9, 2. All right, so those are just 4 points with that. And you can see that this is a function, right? The x values do not repeat. You could look at the mapping diagram. You could make a look at the list of ordered pairs. They do not repeat, so the answer would be yes. The original problem is a function. All right, and that's what we're going to do. However, when we look at the inverse, notice they just took the x and the y and they switched the order. The range becomes the domain, and the domain becomes the range. Now, think about how this is oriented. If I just write the 4 points again, it's 1, 1.4. It's 2, 1.6, and 2, 1.9. This one is not a function. Okay? This one is not a function right here. All right? So we have to be mindful that when we switch the order of it, this new relation, this new point, it may not be a function. It may not satisfy what we're doing here, right? There's a specific kind of inverse function, and we call these one-to-one right here. One-to-one function, all it basically means is that the original and the inverse are functions, okay? So what this means, again, for it to be one-to-one is that not only is the original a function, but after we switch x and y, the inverse of the relation is a function. Okay, and let's look at that with a picture. You can see that here, C and D. One of the common ways when you're looking at a picture is just to see if it passes the vertical line test, right? You take your pencil or some kind of straight line, and I'm going to look at letter C here. Does this pass the vertical line test? And yes, it does, right? But if we want to see if the inverse is a function, we actually ask it to pass the horizontal line test, right? So if I pass it, and yes, it passes the horizontal line test, right? Remember, those two tests are just, hey, does the graph touch my vertical line? The line stays vertical the entire time. Does it touch it just once? That's a yes, it's a function. Or does it touch it more than once? That's a no, it's not a function. All right, you can see here clearly it does on letter D pass the vertical line test, but the moment I try to pass it through a horizontal test, it is not passed, therefore it is not one-to-one. All right, so let's do some quick practice here. You can see right here in example 1, if we look at this here, here's my points, and it says, what is the inverse of these relations below? Well, again, the whole idea is just to switch x and y, right? That's a great first step in finding that. So -1, 0, 0, 2, 2, 3, and 3, 4, right? I could graph these points right here, right? We have a -1, 0, boop, 0, 2, boop, 2, 3, boop, and 3, 4, boop. Okay, and you can clearly see that that's just getting the inverse of the relation, an inverse of a set of points here. All right, we might take it a step further here. These are the same problem, but we're just asking, hey, is this original problem, yes or no? And we could say, yeah. And the reason is no x's repeat. Right? That's a good way. Passes the vertical line test. Here, again, I'm just going to copy down my ordered pairs from above. Right? Because that was just switching it. But now the question is, hey, does this inverse, does it also pass the vertical line test? Right? And you can see because I switched it that it also passes. Yes, because, again, no x's repeat. Now, I didn't have to actually switch it for both of them, right? Think about it. I could have taken the original and said, yep, it passes the vertical line test. There is not any place on this graph that the points touch more than once. And does it pass the horizontal line test? Yes, it does. This function is determined to be one-to-one, right? So if both are yes, then the function is said to be one-to-one. Okay? So, but the main idea I want you to take away from here is just to taking the points and just switching the order. Alright, let's keep moseying around here. Alright, so instead of sometimes finding, this is the second big thing. First thing, taking the x and y, just switching the order. The second big thing here is actually finding the inverse of a function. Alright, so let's take a look. We'll start at letter B. Letter B, there's two steps. First step is we're still going to switch x and y. Alright, so I'm going to write down the same equation that I saw above, but the only thing I'm going to take is I'm going to say x equals 2y plus 8. Notice I didn't do anything except for switch x and y. Right? That's what you do on the points. You take x and y and switch it, right? The second thing is to solve for y. So when it gives you just an ordered pair, a table, all you have to really do is just switch the order, right? Because it already gives you x and y. But in this case right here, it's asking for an equation. So we have to take x and y, switch it, and solve for y. So just like I would, I need to get y by itself. So I'm going to move the 8 over. Right? I'm going to subtract 8 from both sides here. And that gives me 2y equals x minus 8. I'm going to divide by 2. And there's a lot of forms that you could take with this. X minus 8 over 2 is an acceptable answer. That's one of them. Many different ways. You could write x over 2 minus 4 equals y. Perfect. You could write 1/2 of an x minus 4 equals y. All of these are just equivalent forms of this here, right? Notice it's x over 2 and 8 over 2. That's how that 4 is happening there. All right, let's try another one. This one here, it says it's just x equals y squared minus 9. So notice I'm not switching even the exponents. The only thing that's moving, just the x and the y switch. Switch and solve, switch and solve. Go ahead, add 1. X plus 1 equals y squared. X plus 1 equals y squared. And don't forget, got to do that square root. That's what gets rid, or at least eliminates there, all of that. And so we have y. Don't forget, when you square root, you've got to keep that plus or minus sign there, right? Whenever you're solving, you want to make sure to include that plus or minus sign, right? Square root of 16, when you were trying to find x, it was positive 4 and negative 4. So this is also got to have a plus or minus sign. All right, I'm going to have these last two. Just switch it and solve it. See what happens. I'm going to pause the video. Hope you do the same, and we'll see what we got. All right. So we're looking at these here. You can see it. Just a side note, remember I'm just switching x and y. When you do this here, make sure that you're solving it the correct way, right? Solving an equation is kind of like got a lot of different layers to it, right? We can't get rid of the radical. Or excuse me, we can't get rid of the 2 under the radical before getting rid of the radical, right? So just kind of keep peeling things away from that. All right, last thing. This is a really good discussion, but I think it's going to go a little bit deeper than we need to right now. But I do want to show you this bottom one here. And it says graph y equals 2x plus 8 and its inverse. So if you wanted to find the inverse, right, what we could do is take, what would it be here? It would be x equals 2y plus 8. Right? And one of the nice things here is we've actually already done this problem just above, and I'm going to continue to get y by itself here. And so x over 8 over 2 equals y. And I'm going to just navigate this here. I'm going to say it's 1/2 of an x minus 4 equals y. I'm going to choose to write that for a reason here. Now, what I want to do actually, though, is I want to graph this equation. All right? And so, let's see here. What do I got? I think this should work. I'm going to, remember when you graph lines, right? We got a slope, we got an intercept. So I'm going to go at 8 right here. Boop. And then the slope says go up to 1, 2, and then over 1, right? I could have gone the other way. I could have gone down 2, but back 1. Right? And so what I'm going to do here is I'm going to make this line nice and long. Here, this is going to be a little bit harder with that. I use this magnifying glass here. Don't tell my wife. There's another point. Right? Always wanting to make those lines nice and long. Now here's the nice thing about this. This is the reason I wanted to show you. And I have basically 3 points here, right? I have -1, 6. I have 0, 8. And I have, 1, 10. Now, I could just do this. Instead of actually graphing this line here, the inverse would be 6, -1, 8, 0, and 10, 1, right? That's the actual points when I take and just switch that. So what I could do is, after I graph the line, get the points and actually just switch them, right? 10, 1, boop, 8, 0, boop, what is this here? 6, -1, right? All right, so we got this here. Let's see. It looks like I'm going left 2 and down 1 here. All right, and now look how this purple line actually looks. And I'm going to compare it with what I have here. See how the y-intercept is -4? And see how on every single time I went up 1, right 2. That's the slope, right? Up 1, right 2. The reason for this is that the inverse and the original function, they always have to intersect or reflect, over this imaginary y equals x line. Okay, you can see that they're just reflecting over that. So that's one of the nice things about inverses. If you just graph the original problem, you can actually just switch the points and graph the inverse of it as well. You don't have to actually come up with an equation, right? Now, if you're finding the equation like we were earlier, then that is something that's necessary. All right, so the thing I want you guys to try here, this is not due. This is not due at the beginning of the next class. This will be due at the beginning of class on Wednesday or Thursday. We're going to spend some time on Monday and Tuesday just reviewing everything that we've covered leading up to this. All right? So the Math Excel for today is just called inverse functions. Inverse functions. And again, depending on your class, it's due at the beginning of the period on 427 or 428. All right, 427 or 428. Also, the same assignment, or another assignment that's due at that same time is the one about function operations, adding, subtracting, multiplying, dividing, and that new one, composition. All right, be good, and I'll see you next week.